everyone, and welcome to JCYARED fifth webinar. This is Ala Aldika, CPQ and Marketing Officer at JCYARED and YARED Shared Services. We are delighted to have you today to go through one of many webinars hosted by JCYARED. We hope this is going to be as beneficial as expected. During this webinar, my colleague Harut Kitabjian, Service Manager at JCYARED, is going to walk you through his presentation to talk more about good after-sales services of pumps and boilers, from testing and commissioning to corrective maintenance. However, let us start with a small introduction about our company. YARED was founded in 1860. However, Société Jean-Claude YARED was established in 2004. JCYARED Offshore was announced in 2010 for abroad activities. The need for expansion made JCYARED Group Holding a necessity in 2019, grouping all the entities, followed by JCYARED TI and JCYARED Switzerland in 2020 and JCYARED France in 2021. From 1860 onwards, JCYARED has been contributing significantly to the construction and expansion of Lebanon, while successfully maintaining its position as Lebanon's premier supplier of building materials, oil and gas equipment, and services over the years. Our vision is to lead by excellence the oil and gas and building materials industry by covering a full range of products and becoming the preferred one-stop shop. With the commitment and passion we have for this business, we aim to continually improve and distinguish ourselves by diversifying our knowledge and skill sets. Our company serves the Lebanese and regional markets with their needs, always looking for new challenges. Over the last 160 years, we've demonstrated that we have the best professional experience thanks to our wide assistance and professional attitude. Continually working to make the workplace more diverse and inclusive, we implement inclusiveness and diversification at JCYARED because we believe that variety always makes a difference. For the aim of growing an innovative, sustainable, and healthy environment, we are always looking for local talents to join our company. We sincerely believe that with the help of a highly effective, professional, skilled, and powerful selected team, we have no restrictions or boundaries in our future endeavors. Our service team successfully responds to market needs and works to provide the finest after-sales services to achieve client happiness. We are always ready to assist. Our range of supply is, but not limited to, steel pipes, valves, flanges and fittings, industrial pumps, water pumps, HVAC, fans, refrigeration systems, heating systems, manhole covers, fire systems, groove fittings, support and fixtures, iron pipes, plastic pipes and fittings. We integrate our core competencies with our business partners, highly rated and reliable manufacturers from around the world. So as mentioned earlier, we are now in France, Ivory Coast, KSA, Iraq, Lebanon, and Switzerland, always planning for more expansion in the coming future. Our services and solutions cover various needs for the construction sector and upstream oil and gas, MEP consulting firms, MEP contracting firms, midstream oil and gas, wholesale distribution, infrastructure, and service industry. We are proud of being part of the following highlighted projects. First, projects based in Lebanon. We were part of Beit Misk, AUB, Admir, MEA Training Center, Ciel et Jardin. We made a huge difference in Ivory Coast in a short time. We are present now in JH 153 El Daco, Laguna Project, Baobab Project, CDE Project, Sucrivoire Usine, Novotel Adagio, DMD, and Palmsy. Of course, not to forget our contribution in Misan Oil and Gas Project located in Iraq. Thank you for your attention. And now my colleague Harut will walk you through his presentation to talk more about good after-sales services of pumps and boilers.
Thank you, Ola. Good morning, everyone. It's Harut, Service Manager at JCYARED. I've been in after-sales for around 20 years now. I have begun with water treatment plants, pumps and systems, and recently gas boilers. Today's presentation will be on the different steps of the after-sales services, starting from installation, testing, commissioning, till corrective maintenance. Let's begin with the importance of the after-sales services. When you buy a product, a pump, a boiler, or other equipment, it is very important to have the right installation and maintenance to ensure the smooth operation and the longest running period without any unexpected downtime. Today, I will talk to you about the steps of the after-sales service. It begins with the installation of the product, testing, commissioning, and on the later stages, the maintenance, which is divided mainly in three categories: predictive maintenance, preventive maintenance, and corrective maintenance. Then I'll be talking about some problems I have seen during my career. Let's begin with testing and commissioning, generic installation and startup checklist. In this section, I will put my focus mainly on pumps because of the multiple types of pumps and applications. Let's say a 300 kilowatt pump has a very different requirements of installation than a half a horsepower domestic boosting or lifting pump. A 30 horsepower boiler pump has a different installation requirement than submersible pump. To have successful startup, every model and every application has its own checklist. The best guide for the installation of a pump, it is its own installation and operating manual. If a pump or any equipment is installed correctly, testing and commissioning as well as the maintenance will be a very fast and smooth operation. First of all, the technicians must read and understand the installation manual of the pump to install it properly. For example, a larger and heavier pump is required to have a better, proper foundation and vibration damping pads. The alignment of the foundation is very important too. It can prevent vibration and misalignment of the coupling. If a pump is not properly grouted or fixed on the foundation, we'll have vibration issues. Then we have the piping. The pipe needs to have their own supports. It is forbidden to have a pipe and accessories weight pressing the pump. This will result misalignment. The pump will vibrate and lifetime of the pump will be shortened. The electrical wires have to be isolated well and well tightened. We cannot forget the ground connection. It can prevent electrical shocks and injuries. Next, we have to fill the system, vent all the air out from the pumps and the pipes, and connect the electrical power, check the shaft alignment, and correct it if needed. Now we can start the pump and check the direction of rotation, the current, the pressure, the flow, and compare it with data sheet. After 5-10 minutes, we can check the temperature of the motor, the ball bearings, and the pump. And we can check if we have any noise or vibration. Now I will talk about the foundation, some more details. The weight of the concrete foundation varies from around 2 to 5 times the weight of the complete pump with the motor base. Unfortunately, in some installation, they're ignoring this, and which leads to vibration and noise in the system. Here's some right and wrong examples of the foundation. The base of the pump must be in direct and full contact with the foundation. If the base is not full contact with the foundation, we will have a lot of vibration and noise. Vertical multi-stage or horizontal end suction or a split case, all the pumps must be in full contact with the foundation. If we don't have the full contact, we have the base to be bent and we have a lot of vibration. On the left, we can see a perfect installation example. In the middle and on the right, we don't have full contact between the base and the foundation. Definitely bad example of installation. Vibration dampers and isolating pads isolate the building from the foundation and the pump. Let us not forget the expansion joints or the flexible grooved coupling connection between the pipes and the pump. Will isolate the pump from the building too. Now the vibration and the noise is limited to the pump only. Here's some example on how to properly install vibration dampers. We can see the pumps are fixed on the foundation and the foundation is isolated from the rest of the building by the dampers. On the right, we can see also the flexible expansion joints that isolate the pump from the pipes. Just another example of the foundation and the vibration dampers. Grouting the base for large pumps. Grouting or fixing the pump on the foundation is very critical. It can result vibration if it's not fixed properly. We can have also coupling damages and even damages in the pump or the motor bearing. The foundation and the pump must become one rigid part. We have to not forget to use shims to correct the soft foot if available. The soft foot is when we put the pump or the base on the foundation and we have some clearance between them on some points. Here's some example of the fixation of the base. We can see here the base, the foundation, and here you can see the shims to correct the soft foot. The shaft alignment check and correction is very important during the testing and commissioning. Or we can have vibration, noise, and even damage the coupling or the motor or the pump. Now I will talk to you about the submersible sewage or drainage pump installation. On the left, we can see an example of the auto coupling installation. The base is fixed to the foundation and the pump is sitting on the base. The pump can be easily raised out of the pit or to be installed through the guide rail without dismounting anything. We have to make sure that the motor is always submerged in the water to prevent overheating. If we have a submersible pump with oil cooling or cooling jacket, we can have the water level to be as low as the volute. Here's a bad example of a submersible pump installed with auto coupling, but without any guide rails. Also, the pit has some rocks, sands, and other can damage the pump, the volute, and the impeller. Without guide rails, the pump can get loose when running and get damaged. You can see here the guide rail is not installed. Direction of rotation is one of the main issues. Wrong direction will damage the impeller and the wear rings. Also, in the testing and commissioning process, we have to check and set the air pressure of the pressure tanks or expansion tanks. As required, we have to check the vibration noise, temperature of motor and pump, pressure, flow, current, voltage, frequency. We have to read all the data. If the all the readings matches the data of the pump, you can now set the current protection settings and all the control settings such as starting pressure, stopping pressure, float switch level, timers. It is better to recheck everything after 2-3 days of running. We can have some fine tuning after the system is fully operational. Here's an example of the readings to make during testing and commissioning. And on the right, we have the performance curve of a pump. Every collected data must be match the data sheet. Like I said, the flow, the inlet pressure, discharge pressure, differential pressure, supply voltage, frequency, current consumption, temperature, vibration levels, noise. Now I will talk to you about gas boilers, about the installation requirements and the testing commissioning steps. We will see in the following slide all the points: the minimum clearance, the fresh air intake, inlet, the exhaust, the water circuit, the gas type and pressure, and the performance. Minimum clearance data and other data can be found on the installation manual. We need to have free space to isolate the heat from other parts of the building and to make sure there's enough space for maintenance. Here's some examples on the fresh air intake and exhaust. It can be separated pipes too. Here's an example on the water circuit. On the left, we have heating system and instantaneous hot water system connector. On the right, we have the system heating, the radiators, and hot water storage tanks separated with a 3-way valve. After checking the installation, we have to check the gas type and supply pressure and tuning the minimum and maximum pressure of the gas. Now we can purge the system and test the operation. It is a good practice to check the supply and return temperatures and make sure that all the radiators and the return valves are regulated and the delta T is in the acceptable range. Now we'll pass to the maintenance. The first type of maintenance is the predictive maintenance. We can determine the failure before it happens by collecting data and by having some analysis of that data. Data can be vibration levels, thermal imaging, or temperature reading on some critical points on the ball bearings, on motor, on the pump, and data from comparing to performance curve. Collecting data on a long time and analyzing it will give us the gravity of the problem and the approximate time of the failure. We can plan for corrective maintenance without having an unexpected stop of the equipment. The advantages of the predictive maintenance is the reducing of the unexpected fault and cost. Earlier we can correct the problem will cost less. The preventive maintenance is when we perform a regular check and tests such as visual inspection, checking for abnormal noise, can check the pressure tank air, can test the pressure sensor, the automation of the system, as well as shaft alignment, greasing the ball bearings, cleaning the strainers. All this is in the preventive maintenance. The advantage of the preventive maintenance is also reducing the unexpected stop of the system. And of course, it will cost less. Now, the corrective maintenance. The corrective maintenance is when we have scheduled the maintenance to correct any fault determined in the preventive or predictive maintenance. Also, good practice is to find the root cause of the problem, the root cause of the damage, and resolve it to prevent repetition of the same issue. Now I'm going to show you some pictures of common problems. Here we can see the damages made by cavitation on the impeller. It looks like corrosion, but it's not, it's cavitation. We have to make sure the MPSH calculation, make sure it's in the limit to prevent having these problems. One of the common problems also is the limestone. The high calcium in the water has a very bad impact on the pumps. The hard water can damage the pump if it exceeds its limits. Every pump has a limit of hardness for the water. On the left, we can see residues in a wet rotor circulator. We can also see the impact on the mechanical seal. It's blocked and we have leakage from the pump. On the right, we can see on a water heater. Here we can see the damage on the surface of the mechanical seal due to dry running. You can see all the cracks and we have for sure leakage. And here we can see damage of the leakage from a pump and all the corrosion made. The ball bearings are damaged, the rotor is damaged, the winding is damaged. We can reduce the cost of the maintenance if the leakage is corrected on all these stages. For the conclusion, we can say that a good installation, a good testing and commissioning, and a good maintenance service will prolong the operation life of any equipment. Thank you.
Thank you, Harut, for the valuable content. Please feel free to ask if you have any question. You can send us on your question on the chat or just raise your hands and we will give you the permission to talk. Okay, so I believe we're good. Now, please, if you can take a minute. Okay, so we have a question in the chat box. Can you kindly show your contact details again? Yes, sure. Definitely, we will send you our contact details. Mr. Harut, if you can please just share your screen again. Okay. That's it. Thank you for attending this webinar. Your presence is valuable to us. We hope that you answered all your questions and clarified the key talking points about good after-sales services for pumps and boilers. Your feedback always matters, so stay tuned for our upcoming webinars.